Hello, everyone. My name is Mark Anderson, manager of the Manufacturing Solutions Group here at Saratech. On June 5th, I delivered session one of building a digital thread across design, simulation, and manufacturing. What I'm going to do today is I'm going to deliver session two. And what that's going to do is it's going to take over from session one, and it's going to take the same exact storyline that I went through, where we have this digital vane actuator. We had to do some FEA analysis. Quickly, we realized that the thickness and the radii were the cause of the failures, which then led us to our manufacturing engineering concept. So this is showing the process through Saratech's digital thread. Initially, we were thinking a four-part process. It led itself down to a two-part process. So now that we understand from a conceptual aspect what this part and the stages of its manufacturing engineering looks like, we're ready to start physically developing. So this is going to be from top down, as if we have a developed product that we then need to manufacture. So here we're going to start the session two, and the PowerPoint that you're about to see, that's traditionally developed and distributed by a colleague of mine, Adam Cassidy. He's an excellent Teamcenter architect. He does an excellent job with this demonstration. So I left it pretty much intact. And I would recommend that anybody that has a desire to understand Teamcenter or how it applies to you or how it would help you, I would recommend that you reach out to Madison Rye. She's the vice president of PLM here at Saratech. She has a team whose Adam is a part of, who them and I deliver a very comprehensive and excellent demonstration that goes into much more detail than what I'm about to show today. Today is a day in the life of what it looks like to work in an NX CAM managed environment. So there's going to be four key points. We're going to be accessing data, NX integration, leveraging workflows, and reports and compliance. So first part of it, I'm not going to go through this because there's 20 some slides here, so I want to get into the meat of the process here. So I'm going to just go through it. Robust search and traceability, data entry process, the visualizations. These pieces are key to the speed in which you get to the data that you want to. Traditionally, we're used to just using file explorers, and we have to really tune in our search options and our file assembly load options. Teamcenter takes care of all that. We don't have to worry about that stuff anymore. So ease of navigation, streamlined search, traceability, and the powerful visualization tools. All of these are within Active Workspace. What I'm going to be demonstrating out of today is the rich client version. It's more of the Windows-based File Explorer methodology, but that, again, is where Adam comes into this. He does an excellent job at showing all of the dashboards, all of the graphs, and all of the charts that can be easily generated and looked at from Teamcenter interface. NX integration. How does Teamcenter integrate with that NX? What does this new interface look like, and how does it affect the user? So I'm going to be showing you a start to finish process that'll really give you an understanding of what does it look like from a user perspective. Workflows. This is one area that we won't be getting into because you have to develop these workflows to be able to show them and work through them. Adam does have some generic workflows that he is able to process different changes and revision changes and things of that nature. My demonstration is going to be showing as if we had a revision B, and we're working from that released data. The workflows, they can be as complex or as simple as possible. The one you're looking at now, this is something more indicative of an entire parts product lifecycle. And this can be something equated to, I have a part, it has to go to stress relief goes into quality releases it to manufacturing, op one, stress relief, so on and so forth. So you can have very, very complex workflows, or you can have very, very simple workflows. So where I'm going to be showing this process here, how it applies to this demonstration is, once I have my manufacturing engineering plan and I have all the data that I need and I've generated that manufacturing engineering plan, I'm going to start to show more of a complex workflow without the tiles that show this can be disseminated now to your entire manufacturing group, from your CAM organization, your quality organization, in those organizations, the entire project, each piece can be being worked on by separate individuals without no worry about data back and forth, or are they working on the right stuff, or do they have a comprehensive model that they're able to do their work off of. So here's a slide. The reason why I kept this pretty much intact was because I'm sure Andy's going to upload this, and I wanted everybody to have the data to be able to review. So these are key pieces on why it's very important to work within a managed environment. Leveraging your workflows. So workflows, you can get your change requests, your relevant data, submit another workflow. You can configure the workflows. You have flexible participant assignments, meaning you can add or remove people to this flow chart. Easy designated of affected by it and consistent managed process. That's the most important piece, is that at a moment's notice, anybody that's not involved in this project can click a button and see the process and the project status. And here are some of the different graphs and charts that are easily automated and generated from within Teamcenter. So now we're going to start to get into what does it look like. So this is my project demo, and some of the pieces that we're going to be watching, I want you to look for, is the interface, how it allows for a simplified collation of data in a unified area. All the items have been verified, validated, and are viable for use. So that's a key piece. So a lot of times where you have maybe 6 different people in your programming department, and each one of you are using the same vice, but a different assembly. And those assemblies have been modified and manipulated by each individual person that don't necessarily represent the actual vice that is in use on the floor. So you have to have things that are brought in by an architect, they're saved into Teamcenter, and they're validated that everybody uses. So I'm sure some of you run into the issue of where you do have one vice, but you have to make copies of it, and you copy it into each individual project, because if you do things like move jaw widths open or closed, it blows up pre-existing programs. Your toolpath goes out of date because those jaws physically move in those programs as well. So that's just a matter of training. There's a function called override position, and that will allow you to have one vice with the correct assembly constraints, a move or a distance constraint on the vice jaw width that allows for max close and max open, and then you override it, and then you can put your own value in your physical program, and then it just becomes an instance of the original instead of a full complete new project or a part or assembly. So all common fixtures, tooling, speeds, feeds, all other tooling and machining parameters are shared between all users. Your workflows can be leveraged to allow efficient processing. This was where I was talking about your entire user group is able to work at the same time. All the data is disseminated throughout the user group in the proper order. Meaning if all of my operations can be ran simultaneously, then they'll be disseminated simultaneously. If there is a particular phase like heat treating or stress relieving that stops further processes, then that process will need to be stopped and have an approval. Once that's done, then it can be disseminated to the rest of the group. Using a correct process strategy and modules allows for multiple user interaction. And I'm going to be showing this in detail because this is a lost piece in industry. I think it's a very important module that does not get used by a lot of people. A lot of manufacturing companies think I only manufacture, I don't design. That's true, but you also develop fixtures, and so you do a lot of designing. And then sometimes you manipulate parts to get better tool paths, which is also designing. So there's this module called stage modeling that allows you to physically create each individual operation representation for each individual stage. That allows for physical representation of each CAM file. So that allows for the volumetric operations within NX to be used much easier. It allows for the software to be able to understand what it's able to cut and what it's not able to cut. So you can turn the software loose on allowing it to understand and process the correct operations and correct tooling. It allows for better automation as well. So simple to understand dashboards show progress and outstanding tasks and who they lie with. So at this point, let me go ahead and go into the interface. So this right here is the active workspace window without active workspace turned on. So this means that I'm just inside of standard NX, And when I go in here and I use the open, I get a standard Windows type dialog. So first thing is everything is based upon a project type. So a project folder or a number or something to identify this particular entity. So for this, I have my own folder and I have one that's called CES. So the first thing you're going to notice is that all the components for this project are listed in this one folder. So of this, I actually have an assembly. I have each individual assembly component. And then I have multiple revisions of the one component. So we're going to be paying most attention to this component. So if I expand this, you see I have a drawing. Let's double click and open that. So you see I have my drawing. Let's go back to this. Let's go back in and open the model. Now I have my model. So right here is where most people, they miss the opportunity to be able to go much faster downstream if they take a small amount of time here. So at this point, generally it gets kicked out to manufacturing and they say, create this, here's your stock. So that's going to leave me the representation that I talked about last CES session, where we're going to cut this all the way out of stock, leaving a hat, what we call a hat in industry, that's vice stock. So the true representation is there's not going to be radiuses down here. The part has chamfers. It's not, those aren't going to exist. And there's going to be a physical part here. So in your CAM file, you're going to have to manually tell it to stop and do these things. So it's manual interaction and interdiction from the user to get what you actually need. The easiest way to go about this is to physically create everything all at once in a project stage model type of operation. And how do we do that? First thing we do is go application, this more tab, stage model. It's taking this original, and then we say there's going to be one more. We give an identifier. I'm using the automatics just so it's simple. Now it says this is my original. I'm going to go ahead and link this geometry. Now I'm working on this as my stage. First thing I want to do is go in here, turn it to its side, and then I'm going to remove the lower chamfers. And also these chamfers, this just removing any type of radius out of something really assists you in the long run with doing synchronous modeling. So now that I have that taken care of, that's partial representation. Because these are full radiuses, it becomes little trickier, but not too terrible. So first thing is we're just going to say, I want to do a sketch. I'm going to do that sketch on this surface. Draw me a couple lines, making sure that I have my assembly or my quick pick set correctly so that I don't pick some erroneous spot on the curve. And I want to pick a line that goes this way. Make sure that my lines are 90. $180, which it is. Draw me a nice arc here, center point arc. Trim up some lines, and then I'll have my blade that I need. Now I'll go in here and just do some extrusions. And here's a little quick tip for you guys. The selections here, many of you might have used the until selected, and you think that it's not working. I mean, it truly isn't working for doing the automated portion of it. But if you just use it and then change it back to value, it retains what you've selected. So just a nice little trick for you. We're going to use the other direction. until selected, and it retain the values and work just the same. Another extrusion. This time we're going to do it from a centered location. Use a rectangle. And then this one, I know my stock is only going to be 1/8 of an inch all the way around the part. So I can prepare this blade already for the stock that is to come. This will just set me up to make things quicker later. And once I have this, I tell you, I use the until selected. It's everything. $125. We'll go $250 on this one. Uniting to that. Okay, so now we have our first stage. This is what it's actually going to look like in the vise once we're finished with it on operation 1. So now what we can do is we can go ahead and save this portion. And then we can go through and automatically generate and derive its stock and keep it all within the project. Derive stock, assign it, select the model, tell it there's a 1/8 inch around it, which we've already prepared it for, except one of these sides is not 125. One of them is the stock. So we only want stock on one side of that. Also, at this time, I'm going to go ahead and I'm going to start preparing this for the different parameters that I always choose when I do programming. Stock is brown, 50% translucency. Now, when we do this, we can save this here. And then we'll say that this part, our stage model, is actually and now it's trying to save right now. Okay, so now that it's saved, now my stage model, everything is saved into the project folder. I'll come back over here to my first stage. I always have my first stage is blue with 0 translucency. That way I can easily identify them. Okay, so now I'll go ahead and save. Closing the entire stage modeling project. And then we'll go back through and show you the, sorry about that, and show you the new folder. So now I have my stage model, my stock. It's already set up for us. Now I can go ahead and start my manufacturing. So I'm going to go back into my part file. And this is my finished part file. It will not allow you to open up a stage model and start it as your original master. You want your master model to always be the original part file. We'll go to File, New. Now what this does is it's going to bring up our Teamcenter dialog. We just have to assign it. We're picking a general template, saving different locations. And you notice that all of my load options, all of my saving, everything is already taken care of for me. So now that I have this, everything remains the same as it always has been before. Everything that has been approved and is inside of your Teamcenter environment will be available for you. We'll choose Sim 8. Now, as I mentioned, for your vices, all of those different things, once they're in the system, they're available for use. So once I get this where it needs to be, I'm just going to put it in space somewhere. Now I can go after my picturing. So once I'm finished here, assemblies, add a component, go into my vice folder. Here I have my vice. I'm going to use assembly constraints on this one, concentric. Then move. Now I'll move a component so that we have it 90. So then now once we have this set up, I'm not going to go into detail about putting my part in place and everything of that nature, but this part here, our main part, isn't what we're working on. We want to add now the base link. So if we go back up to my folder, we'll do stock first. Using our assembly constraints, I like to move my part first. We go 90. But you see, everything is the same, exact same as it would be when you're traditionally working with NX. Once you get to this point, we would put our part in place. The biggest thing that different though is we would be able to allow the software to work. So let's turn this simulation kit off. We're traditionally used to, oh, what happened here? 2 to 2. We're traditionally used to working in an unmanaged environment to where we're manually putting things together. We're manually trying to find all of the components. We're manually trying to tell the software where to cut, where not to cut, leave a fictitious hat on a part, don't leave a fictitious hat, which then it makes us have to rely on a manual portion, a manualness about NX, which we don't, that's not how NX is meant to be used. And I'll show you with this part here. So now that I have this, I'm going to go ahead and turn on my stage model. I'm going to add that as well. Using a sound, I'm going to move it first again. It's just simpler to move it in my mind. Some people may use assembly constraints to make things parallel and perpendicular, but it just is a little bit easier for me to get things out into space, and then I can start constraining things. So once I have the model constrained, you're going to notice that I'm going to just take adaptive milling and I'm going to let the software go at it. I'm not going to tell it that it has to stop at any specific cut levels. All I'm going to do, and a matter of fact, I'm going to try to use feature-based manufacturing to allow it to do all that it needs. So that's going to showcase all of the different things and the automation that can be done within NX when you use all the different modules to their fullest capabilities. So now if I go in here to manufacturing, I'll set my work 0, center of rotation down here. Tell it what my workpiece is, what my part is. So first blank, then we'll tell it what my part is. And then we'll tell it that everything else is a fixture. So now it knows not to cut. And we'll tell it that that's the physical work piece, which now helps us jump right into simulation. So now that I have the entire environment set up, this is where NX really shines on what it's capable of doing. We're going to ask it to find any features that it can. But first, we got to make sure that our work 0 allows for all access, which it does not. So let's go in here. Does not as well. So let's add one. All access, okay. So you have to have all access registered or it will not allow. Or feature-based manufacturing to find out any of the rotational pieces. So now that we have this, now that we can find features, it's going to look at the entire part for all of, let's check everything. Now it's interrogating the part. It's found all of these different features. Let's see what NX is capable of understanding without me having to interject anything. It's processing through the feature-based manufacturing MKE editor, your tooling database, operations. It's trying to pair them and create the adequate information to cut this part. So now let's see, what was it able to understand? So you see it understand quite a lot. Let's see the generation of it. Okay, let's see what it understands. Even if it doesn't understand a lot, you're going to notice that it's doing a lot on its own. So with a little bit of fine tuning, it would be able to do this entire part by itself. It just has to understand the parameters in which it's working. This is an out of the box system, so I didn't expect it to find much, but let's see what it found. Hide our part so we see an accurate removal. So it's found its own paths to find planar milling items. So you can see that it has a system at play. It didn't cut the vise, didn't give any type of collisions. So let's delete this. Now that we have some tools, let's go in here and create an operation. And I'm going to use adaptive milling, and I'm just going to use the 7/16 end mill roughing. So without changing any parameters, let's generate this and see what it does. So you're going to see it's going to cut everything it possibly can without colliding. That's the software understanding all of its parameters. So I use an analogy here lately. It made sense to me when somebody else told me this. You think about us programming CNCs nowadays exactly the same as pilots flying 747 jumbo jets. They don't fly those airplanes like fighter pilots anymore. They put in inputs, parameters, and the plane reacts. So we need to figure out a way to be able to put as much data into the system so that it can then turn around and figure out the best methodology to do things. The days of us controlling all of these different items, it's over. We're going to be less than efficient if we try to take as much control from the software as possible. So now you see I have some area left. Very easy. I just would create an additional, and then I would choose a smaller tool using the 3D IPW. Doesn't look like we have one, so I'll just go and grab a 1/4 inch or something. This is all coming from libraries, what the feature-based manufacturing system is built upon. Making sure that my 3D IPW is turned on and just regenerating. I'm not having to go out there in active space and touch the part, select surfaces, do anything like that. So now you've seen what it looks like to go from one to the next, from modeling, stage modeling into manufacturing. Now, how do you perpetuate operation 2 and using the models in the correct methodology? So you see it's gotten down in between the jaws where it can. It's trying as hard what it it's trying what it can so that you can not have to do as much work, you not have to select the part, not do those different things. So now what we would do is we would just create a new file. We'd come back here, we'd do file new item, just like I did before. And then we would do a wave geometry link and copy our machine and our setup, our tooling, everything into the second operation. Now, for time's sake, I want to make sure that I'm able to get into the quality side of things. So the same perspective, I've now have my operation 1 part that I have one programmer that just wrote. At the same time, my programmer started operation 2. Now, the way you perpetuate a file correctly from operation 1 to operation 2, we're all linked through everything. So I know I'm using this. I know I used all of this. Everything worked just fine in this one. So then what I would do is I would take all of my tooling, and you can go, it's not going to let you do each individual, you'd have to do each individual tool. So we'd grab this tool and this tool, copy them, paste them into the other spindle. So it only grabbed one because I pasted it inside. So I grabbed 60. Let's grab this one. And then we would add our machine. Now, when we went into our stock, we would take, this is our part, but our blank would now become an in-process workpiece of 20113A, this workpiece. Update, it says that it's out of date. So that's how you would perpetuate. I would have to finish this file before it would allow me to do this and save this. Once I saved it, then it would let me use the stock in as another. Now, how do we go in? So now, as I was finished saying, that's 2 manufacturing people programming at the same time with accurate models. The same exact thing can happen with the CMM. We can send the link, the stage model, operation 1 to the CMM to make sure operation 1 is fine. We can send operation 2 to the CMM to make sure operation 2 is complete. We can do it simultaneously, or we can do it in tandem. So if I wanted to create my quality, I would just go new item. I would choose the quality tab. We'll choose this Wenzel, give it an ID. And because we put PMI data on and not just put did or draft, what that PMI data does is it allows us two things. It allows us to auto-generate the draft, and then we do very little work there. But then it also allows us to automate our programming off of it in manufacturing. That's how we can not just drill a 260 hole, we can do a fine bore or a surface finish. We can bake them into the feature-based manufacturing. But also, we go in, now I have this quality where I'm doing a inspection. I have my CMM program. Now, all I have to do in here is go link to PMI. It says this part, any probe. It automatically pulls that data, and it does just like feature-based manufacturing does. It'll automatically generate features, inspection pass, and it'll pull in its tolerances, if any. Now I can come over here and generate. They move things, verify. Oh, I don't have a simulation kit in here. Okay. So you're going to have your collision avoidance capabilities here. You can do your alignments, and all of your information for your CMM now is up here, and your program is here. Then we can output to DEMIS. So your entire project from start to finish was wrapped up into one folder. All of its corresponding pieces are in the correct respective folders. Any additional items that were created were also put in the same folder. So at the click of a mouse click, you have the ability to have all this visualization. You can see what its status is. You can say that it's been released. These are all unreleased. You can see when the status is, the date release items. Big things when you open assemblies, no assembly load options. It finds it through the folder structure. All of this data is encrypted incoming and outgoing. So if you have, say, you're working on a large assembly and you're working from a remote location, generally Teamcenter will cache all that information, and then you'll be working from your local, and then it will release it back to the original server once you're done. So this Teamcenter environment, for a managed environment from a manufacturing and a quality perspective, it is amazingly efficient, brings all the data quickly to your fingertips to be able to quickly process things. But one of the biggest things for this demonstration was being realistic, taking the time to creating these stage models so that you have a robust data structure throughout all operations that allows you to be able to process your parts simultaneously through user groups. Then at the click of a button at a moment's notice, you have all the dashboards at your disposal. The biggest thing for this was to show you the higher level overview. It was to spark your interest on all of your respective pieces, things that involve and affect you. I'm sure that if you see something that you like, you're going to want a more comprehensive demonstration. So with that, I thank you.